We're going to talk about plasma one more time, and this time we're going to talk about plasma that's really high energy. So this one is about 20,000 volts. And what's going on here is we're using, again, that transformer from the 120 volt in the wall, and because it's alternating currents, we can transform that energy up to 20,000 volts with the transformer. A lot of energy here now. Now this plasma is dangerous. That's why there's a glass around it. We don't want to touch it. So plasma is a high energy gas with high temperatures. So this is an example, and it's a practical example, of how welders weld steel together, or iron, or whatever alloy they're working at. So you take the welder's rod, which is connected to the power supply, and you ground the piece of steel that he's working on. He connects those two together and pulls an arc, and that's a plasma arc, and there's high energy, high temperature. It melts the steel and the rod together very, very quickly. So very practical, but kind of dangerous. So this is not one you want to play with at home. And this device that we have here is called a Jacob's ladder. And that was invented by some cool guy long, long ago. And the idea is that he's got two electrodes and they're shaped in a V. And the closest part at the bottom is where the arc initiates. And because it's a hot gases tend to rise, right? It will go up the electrodes, up the Jacob's ladder, until it's so far apart that it cannot sustain the arc, and it extinguishes itself and says, okay, I'm going to start again. It goes right back to the bottom. Because like most things in life, we take the path of least resistance, and that is that little tiny space in between them at the bottom. Okay, called the Jacob's ladder, but this is a great example